Okay, so thanks for joining, guys. We can start today's session. So last class we have been discussing about Docker, a technology called Docker, and how we can use Docker in ROS. Okay, so we have seen how to install Docker on Ubuntu and how to run ROS application. I think we have seen some simulation, right? We have run the Docker and we have seen how to launch Gazebo from Docker. Okay, so that was we have been discussing last class, and so today I'm planning to continue with that topic and very close topic. I mean, very the topic is very connected to Docker. That is the testing deployment thing, continuous integration and continuous deployment. That also we can discuss, and also like how to release a ROS package. So most of the things are like in tutorials. So I will be like going through the tutorials and discussing that. Okay, that is what I'm planning to do. Even even for the next topic that we are going to discuss, that is NVIDIA Docker. That is also like I will be explaining how to do. Okay, I can't able to demonstrate because I'm working from VMware. It should require an actual system to demonstrate. I will explain that anyway. Okay. Yes. So the first topic that we are going to discuss is working with NVIDIA Docker and ROS, and working with ROS Gazebo Docker. I mean, basically, this topic actually covers how to interact with Docker and NVIDIA drivers. Okay. So before starting that, maybe I can show you some images so you will get a clarity. Okay. Yeah, I think this will be good. Yes. NVIDIA Docker installation. I'm just sharing it. Just a second. Okay. So this is one link, and this is the installation instruction. Yes. Okay. So let me come back to the topic so you will get a clear idea how the NVIDIA Docker works. Let me take some images. Yeah, I think this image, yeah, this is good, and this is also fine. Docker engine. Okay, first we can start with this. So guys, so we have discussed about the Docker, right? Docker, what is the Docker engine? Maybe I can also take that Docker architecture. Let me take it, or just Docker. Yeah, this one. And yeah, that will be fine. That will be fine. So here, this is the architecture, or this is a block diagram of Docker that we have seen in the last class. Okay, and this is the comparison between Docker and virtual machine, which is mentioned in the Docker website. Okay, so guys, you can see here there is a fundamental thing missing in these two technologies. So in case of virtual machine, what we are doing is we have a program called hypervisor, and the hypervisor is actually allocating hardware for the guest application, okay, or the virtual machine, okay, and you can set up some application on that virtual machine. Okay, you have to install some guest operating system on it, and then some application you can run. Okay, so the problem is that the hypervisor can't able to share all the system resources. For example, most of the hypervisor only support CPU sharing, RAM sharing, mostly. Okay, only limited hypervisors or limited virtual machines will share the graphics card or graphics resource. Okay, so mostly like if you are working with um, gaming laptops, for example, in my computer I'm using an old one. It's a gaming laptop. I bought it in 2017, but I have a graphics card, and you can see obviously if you have a processor, it will have an inbuilt graphics card, right? So that is what you are seeing, the Intel HD graphics, and I have an old graphics card, that is GTX 1050. Okay, so in case of VMware, if you take VMware, I'm just taking its main window. Let me take, okay, in case of VMware, if you take one virtual machine, these all are the list of virtual machine that I have, and maybe I can just edit another one. So there is an option to increase the RAM size. Like the total maximum RAM size is 16 GB. Okay, because that is the maximum RAM of the host machine. Okay, so there are some limits that you can see. Gust OS recommended minimum is 2 GB and recommended memory is 4 GB. Like minimum RAM is 2 and recommended is 4, and maximum recommended is 13.4 GB. So that is the maximum. If you are allocating the 16 GB, then the host operating system will not get the RAM share. Okay, so then the host operating system will crash. Okay, so you can share the RAM, you can share the CPU as well. Okay, so currently if I'm taking the system task manager, you can see there are, I think, yeah, 8 logical processor, 4 cores. I think there is a question, just a second. Can you please show the same for VirtualBox? Yeah, I will show you, Bharat. So I will start with VMware and I will show you in VirtualBox settings as well. Okay, so there is an option to share the CPU as well. Okay, and if you just go down, there is an option called 3D graphics, accelerate 3D graphics. Then there is an option called graphics memory. Okay, so one of the reason why I am preferring VMware is it is having better graphics memory share. Okay, memory share, graphics memory, but and there is an option called accelerate 3D graphics. So these are the 3D related stuff. There is nothing related to NVIDIA or nothing related to Intel, but just saying like you can accelerate 3D graphics and share your graphics memory. Okay, so the VMware is not a free free software. Basically, we will get a trial version. Okay, and you can use it. There are some limitation in this trial. It's a proprietary one. That's why they have this much of option. Okay, but in case of VirtualBox, okay, if you take the VirtualBox, you can see some limitation in it. So if you take it and if you take the settings of your virtual machine, just go to the system. Here you can see the same settings, like you can share the RAM, you can share the CPU and some CPU related acceleration. But if you check the settings, you can see the video memory maximum is 128 MB. Okay, and you can increase the monitor count, and also you can decide which graphics controller that you want, and there is a 3D acceleration option here as well. So the main limitation in VirtualBox is the video memory. It's too low. Okay, and there is a graphical controller. Okay, so what happening is that these virtual machines are not actually using the graphical resources properly. Okay, because it is using some layers, I mean software layers, to create graphical acceleration. But in case of processor, it can emulate the processor, and also it can share storage, RAM, all this stuff. So this is a main drawback. Okay, so imagine you are going to work with some high end simulation. Okay, uh, a simulation application, and you don't want to run this simulation application on your PC. Okay, directly run.
Yeah, sorry for interruption.
Yeah, no, no problem.
Uh,
Yeah.
I, I'm using the Alienware, and I have a 32 GB RAM
Okay.
and 1 TB terabyte and 500 GB SSD, both like 500 SSD for operating system,
Okay.
and I have the 1 TB SSD.
Okay.
So I'm using 1 TB for this virtual box, and whenever I use the gazebo, it is very damn slow. And I went to the internet and searched it, and I now the system is okay little bit, but the performance is that much not good. Like refresh rate, if the mouse or something is slow.
Yeah.
So how can I improvise? Because I'm using a RTX 3060,
Yeah.
which is quite good for this running for minimum gazebo,
Yeah.
but I'm
So
not able to understand how to improvise
yeah,
my
so this is the
CPU
exact
performance.
problem. This is the exact problem that we are going to solve in this class. Actually, not using virtual machines, but using Docker. Okay, I will come back to that. But in your case, I will suggest, like you mentioned that you have 1 TB of storage. Okay,
Yeah.
so for this storage, don't allocate 1 TB disk space. Actually, like
Yeah. I'd given a 30 GB for that
that
one,
is fine.
and
That is
30
fine.
or 50. I won't remember.
Yeah,
It
50 will
was
be
done.
safer, like
Uh,
if you are going to
yeah,
work.
50.
Yeah.
Yeah, full disk, full desktop. So I using that one, and the cores number of earlier it was 14 cores was there.
Okay.
Now I reduced to two, and the performance was little bit okay based on the internet. Some suggestions I reduced to two. Earlier I given a maximum 14 cores
Yeah.
CPUs.
Yeah. So I can say the solution. So
Yeah.
if the number of processors are 14 and there is an green mark, right? So
Yes,
like
correct.
this is the invalid setting. Okay. So
Okay.
maximum I mean the recommended setting will be this green part. Okay. And
Yeah, correct.
for the RAM as well, if you check the base memory, you can see the green, so you can allocate
Yeah.
that. And regarding the graphics and the performance of your virtual machine, there is a thing called gust additions. I'm not sure you have installed gust additions in virtual machine.
Yeah. I went to the guest editions and did it also.
Okay.
So somehow my graphics card errors are coming, like load and the store that errors related to GPU stuff drivers are not performing. So last time you
Okay.
said you need to disable the this 3D
Yeah.
accelerator.
Yeah.
So when I disable the 3D accelerator, I'm not seeing the errors.
Okay.
But only thing is my number of processors for me it is 28 CPU cores,
Okay.
CPUs are there. So I had given a maximum of green 14,
Okay.
so it was very slow. So some in blogs I read it is you just give two CPU cores count
Okay. Okay. Okay.
processors.
Got it. Got it.
So then it was little bit okay. Means I can open Gazebo, I can this total Sim 3, I can run it and check it. But only thing is the performance was very
Yeah,
damn
so
bad.
I think there are multiple reasons. Like, uh, what I am thinking is like, I'm not sure like the VMware can able to handle 14 core, but I think literally it could able to handle actually. It should perform well. I mean, in the ideal case, that is the expected performance that I am like thinking like. Obviously, we will get the settings in this green range,
Yeah, correct.
and like the system performance will degrade if we have a bad graphics settings, or if the driver of VMware virtual machine is not installed properly. That can be also a reason. But if there is any unknown reason, I'm not sure, because you are actually working with a very high-end PC.
Yes,
But
yes.
ideally it should work. But I will suggest you to try with the VMware as well, because VMware as
Okay.
of now, like it's giving good performance for me.
Okay.
Like it is, I mean, it's quite stable as well. You can give a try. Just
Yeah,
uninstall virtual box and try VMware. Just see the
okay.
difference. And there is
Okay.
another virtual machine software. I forgot actually. Let me just Google. That also give hardware acceleration using GPU.
Okay.
Like
Okay.
just a second. Let me just search virtual machines. Um, just a second. VMware Fusion Send. It's not that. Hyper-V, no. QEMU, no. No. This is not the thing. Let me just go through it. I just work with it,
Yeah,
but
yeah. Okay.
I forgot the name of it. But
Okay.
maybe I can share that maybe after
Okay.
checking
Yeah,
it.
sure.
So my suggestion is like just uninstall VirtualBox and try with VMware for now. And in
Yeah,
this
okay.
class, we will be also discussing another alternative. It's not that much simple as virtual machine, but one of the most effective way of working with robots using Docker and hardware accelerated NVIDIA graphics.
Okay.
So that is what we are going to discuss. Okay. So
Okay. Thank
anyway, like so you guys have already heard some problem with the virtual machine, right? Like Bharat is actually working a high-end PC, but if when he try to run Ubuntu on his machine, I mean, as a virtual machine, it's not performing well. It's underperforming, right? In this kind of machines, we can run actually like 4, 5, or 6, 7 virtual machines at the same time. Okay. Uh, so what I'm trying to say is that if you are using virtual machine, the GPU acceleration is not guaranteed. Okay, especially for VirtualBox or VMware. Okay, GPU acceleration in the sense, if you want to work with some high-end graphics, okay, for example, a simulation or some CAD tool, okay, or some kind of like GPU intensive stuff on your virtual machine, mostly it will not be possible. Okay, even if you are working with VMware or VirtualBox, it is not possible. In some virtual machine it is possible, it is having graphics card acceleration, but most of the virtual machine software doesn't provide that. Okay, so that's where the Docker come into play. Okay, so Docker, if you check it, I mentioned that the Docker is closely working with the kernel of the operating system. Okay, so one of the advantage that we get with Docker is that there is a possibility to get hardware acceleration. That means if you are running a ROS application or any application, you can able to work with the graphics card. Okay, for example, if you are going to run a very GPU intensive robot simulation on Docker, it will use your GPU. It's a big thing, right? Because the virtual machine can't able to provide that GPU acceleration, but Docker does. Okay, so that is what we are going to discuss first, which is the NVIDIA Docker. Okay, so as of now, from my understanding, NVIDIA is only providing this kind of stack. So you can able to see from this image. Uh, so here you can see uh, host operating system. Underneath, you can see the GPU, NVIDIA GPU. That is that is there, assuming that it's there in your PC. So in my case, it is GTX 1050. It's somewhat old one. And in order to work with the NVIDIA Docker, what you need is you need some NVIDIA drivers, which will be already there. Okay, if you are working with Linux, you will have the NVIDIA driver, and on the top we have the Docker engine. And if you have this setup, okay, if you have this setup, you can install the NVIDIA Docker, okay, which is actually an kind of add-ons to the existing Docker, okay, add-ons to the existing Docker. And the final product is that you can able to interact with your graphics card. Okay, so there is no limitation in working with NVIDIA Docker. Like, you can squeeze out the full potential of your graphics card using NVIDIA Docker. Okay, so if you have an NVIDIA GPU in your PC, I will suggest you to try out the NVIDIA Docker. Okay, so this is the instruction. Maybe I can I mean, go through the installation. It's pretty straightforward, and if you run this, you can able to see the driver version. And I mean, this message will be only getting if the Docker container interacting with the NVIDIA chipset or NVIDIA graphics card. Okay, so basically this is what happening. We have the host operating system, and on the host operating system, imagine the host operating system is Ubuntu. On the top we have the NVIDIA driver, okay, and inside the NVIDIA driver mostly we have the NVIDIA driver and the CUDA cores. Okay, CUDA is the GPU computing library for NVIDIA, and on the top we have the NVIDIA Docker. Okay, Docker engine and NVIDIA container runtime for Docker. That is what we have to install separately. Okay, we have the Docker engine, that is the default Docker, and we have to install the NVIDIA container runtime for Docker. Okay, that is what we have to install separately. And on the top of it, you can do anything. Okay, you can do anything. It's not only ROS, but also, like, if you are a deep learning enthusiast, if you want to train your model, you can easily do it. Okay, one advantage that you will get is that there are many framework in deep learning, like TensorFlow, PyTorch, Theano, Cafe. I mean, the list goes on, right? And if you work on some of this framework on your host machine, one of the problem is, one of the problem that you might encounter is some the dependency issue. Okay, because mostly all of the frameworks are working in Python, so you can get dependency issues, and there is a way to rid of it, like using virtual environment in Python you can do. But using Docker you can do it in a very good manner. Like, you can see, you can run different containers. Maybe if you are working with ROS and GPU application, you can run that container. Okay, you can run that image, so it will work with ROS, and you can run any number of images and create containers, and all these containers will be interacting with the NVIDIA driver and the NVIDIA graphics card. Okay, so the difficulty is that you have to, like, understand how Docker works, and also you have to practice, because most of the stuffs are doing by command line. Okay, but once you familiarize the concept and all, I will actually prefer Docker. But most of you are, like, working with without Docker, is that we are lazy basically. Like, we are like person, like, we are not interested to do much work, including me. Actually, I can do this running of Ubuntu and all in Docker. There are two reasons I'm using VMware, because as a beginner I think virtual machines will be working, but after creating understanding of Docker, I think you can slightly, slowly migrate to Docker. So the advantage, I think you got an idea, right? The advantage is that you will get the GPU acceleration. Okay, and how to do that? How to install Docker and NVIDIA runtime? Okay, so the thing is, it's actually very simple only. This is the repository called NVIDIA Docker, and just follow the installation guide, which is actually showing here. So this NVIDIA Docker will be working on Ubuntu 22.04, 20.04, and it will be working on AMD 64. So this is our um, version. Okay, so just follow I mean the instructions, and only thing is that, like, here they are already giving the commands to install container toolkit, all the stuff. Okay, this is what installing the container toolkit, I guess. And this is yeah, this is installing NVIDIA Docker. It's actually NVIDIA Docker 2. I mean, it's a successor of Docker 1. um, they actually fix a lot of stuff in Docker 1. So NVIDIA Docker 2, and then restart the Docker. After that, we can simply use the Docker command to run this command, this NVIDIA -SMI, which will only work if there is a graphics card. Okay, so if you have Linux installed and a graphics card, graphics driver installed, you can run this. So this command basically, like, run an image called NVIDIA slash CUDA 11 point. This is the base image. Okay, so this command actually tried to run this image. Okay, and you can also see a new tag --GPU all. Okay, which is actually, like, specifying the GPU usage, and this is running the this image and creating a container, and then after that running this command. Okay, the last part of this command is, like, after running the, or after creating the container, run this. So the output will be this. Okay, so this is having, like, information like what is the driver version, NVIDIA driver version, what is the CUDA version, and the GPU name and all. Okay, GPU memory, all this stuff. Okay, so it's very straightforward. You can try that. This is the instructions. I can't able to demonstrate in VMware because it doesn't have the GPU capability, right? I tried with my Ubuntu 22.04, which is running on ROS, which is running with ROS to Humble. So I tried with that, and it was working. Okay, so this is an example, guys. If you have a basic idea of Docker, you can also work with NVIDIA Docker. It's not I mean, very tough. Okay, and if you have NVIDIA Docker, then you can able to like, run ROS application, and that will be working with NVIDIA acceleration. Okay, so that is the best way of working with ROS graphics or ROS simulation application. If you have the graphics acceleration, you can run your simulation very fastly, without compromising the need of hypervisor. Okay, so this is one topic that I want to discuss with you, the NVIDIA thing, which is very useful while working with robotics. Okay, so you can try that. I'm not sure everyone having the NVIDIA graphics card with you, but if you don't have the graphics card, then just understand that I mean, understand this. If you have in future, if you are buying an NVIDIA graphics card or NVIDIA based PC, you can use this thing. Otherwise, you can also try it out. Okay, so there is a good readme as well. um, yeah, so this is what the um, NVIDIA Docker architecture. Yeah, so everything is actually mentioned in detail. Yes, so as a roboticist, what I will say is that, like, if you want to work with uh, robotic application, I will prefer NVIDIA Docker. So you can squeeze out maximum performance of your GPU as well as CPU. Okay. Yes. So that is one thing.
Do we need to install, means you are suggesting VirtualBox and NVIDIA, or it is on the VMware on NVIDIA
Uh,
Docker?
yeah. So if you want to work with the Docker, it will not be effective if you are working with VMware or VirtualBox. Like as I already mentioned, the VMware and VirtualBox will not detect NVIDIA as a graphics card. It is actually working in an extra layer, right? So the Docker will be only working on the NVIDIA Docker will be only work if you install Ubuntu on your real PC. Okay, if you install Ubuntu on your real PC, and if you don't want to install deep learning versions like deep learning frameworks or something, you can use the Docker image, and you can run those deep learning framework or ROS simulation using the NVIDIA acceleration. So it is installing Ubuntu on real machine and then installing Docker on it and install this like that. So it will not work with VirtualBox or VMware. But
Okay.
yeah, but for just for learning purpose, if you are just like learning simple ROS commands or simple simulation, VMware will be fine. But if you want to like explore the maximum potential of your PC, uh, or if you are just working with high-end simulation, then I will prefer like either Docker, or you can work on your real machine itself. Okay, if you want some kind of isolation of your application, then you can start working on Docker. Docker is where like we can work in an isolated fashion, because you are running in a container. All the dependencies are inside the container, and that will not affect the real operating system. Okay, for example, in your real machine you have installed some dependencies, and imagine it is broke or some kind of things happen, so it can affect your real machine and you have to reinstall it, right? But in case of Docker, that will not happen. I mean, even if it is a problem, you can simply delete that image and you can redo it again. Okay, but maybe as a beginner you may feel slightly difficult. In that case, I will say like start working with VMware and understand the concept of Docker. I mean, the default Docker, only the CPU acceleration thing. Without the GPU, you can try it out, and after that, after getting some confidence, like um, you can install the Docker on your real machine. Okay, and you can start working on it. So it is actually like you have to do it in a very I mean gradual way. Like if you are not confident, then you can do one by one, like learn one by one. First work on a virtual machine, then start working on Docker, then install NVIDIA Docker and start exploring. Yeah. Okay, so if you have any questions, you can just post. Yeah, so there is a question from Kalpesh: is NVIDIA Docker compatible with Debian? So you can check that here. There is a compatibility checker, right? I think you have seen that. Uh, Installation. Yeah, so here it is. So Ubuntu 22.04, Debian Linux 11. Debian Linux 11 is supported, and I will say Docker in Debian is very helpful because if you want to install ROS on Debian, sometime it may not work good, but installing Docker, especially NVIDIA Docker, uh, you can try it out different versions of ROS and deploy ROS application without installing on the real machine. Okay, so it is supporting Debian, OpenSUSE, then yeah, Debian and Ubuntu are the, I mean, mainly using operating system, right? So it will work, and it will work only with the AMD 64, not with the ARM 64. Yeah. Okay. Yes. So that is one thing I need to have a discussion. Yeah. So Kalpesh is asking, so Debian can be installed as an OS on the machine. Yes. So you can install Debian, then install a Docker and the NVIDIA Docker, and you can start working. Okay. Make sure after installing Debian on your machine, you have to install NVIDIA thing. I think in the installation of this, the NVIDIA driver is automatically installing, I guess. So that you can check. I think NVIDIA drivers are already installing. They're actually mentioning what are the drivers they are looking for. So yeah, so here you can see we need the NVIDIA Linux drivers, which is greater than 418. Okay, and yeah, Docker 19 point not I mean 03. The Docker version should be higher than this. Yeah, so these are the prerequisites. Okay, so I hope you got an fundamental understanding like why we need to use the NVIDIA Docker. What is the real advantage? And if you don't have the NVIDIA card, you can still use the graphics. I mean, you can still make use of the integrated graphics, no issue. But you will not get this kind of acceleration. For example, the CUDA acceleration, all this stuff are like specific to NVIDIA. Okay, so you will not get it. Okay. Okay, so that is one topic I just want to discuss with you guys, which is the NVIDIA Docker and ROS, which is like a runtime thing you can install and you can work on Docker with the NVIDIA graphics card power. Okay, so now I just want to switch to this chapter, which is very closely related to the Docker. Okay, so before starting this chapter, I will give you an introduction that is very important. After that, I will be discussing why we need to, I mean, discuss about this topic in ROS. Okay, okay. So I think we can start. Before that, I'm not sure you have heard about CI/CD. Uh, how many of you heard about continuous integration, guys? Before continuous integration, like
Yeah, I worked on the Jenkins.
okay, great, great, great.
Yeah,
Yes.
yeah, a good experience on
Okay,
that.
okay, okay, okay. So, uh, I think most of you heard about DevOps, right? So it's mainly uh, like if you want to, maybe I can give you an idea. Like, if you want to work with a software, okay, any software, there is actually a set of um, procedure or process have to do, like after development you have to do the testing then deploy then bug fix. I mean, these loops will be always goes on. Like creating a software is not like, I mean, simply code and it's finished. It's not like that. If you want to create a professional software or an application, it involves a lot of steps. Okay, and one of the step that involved is the coding part. Okay, it's only one part of it, but there are many other part uh, in that loop actually. So this diagram actually showing the different steps in a software development. Okay, that you have to I mean consider. Okay, like you have to plan, then code, build, then test, release, deploy, operate, monitor, again plan. I mean, so if you check it, what happening is that, like, after creating or after coding, you have to build the code, obviously, then you have to continuously test it. Okay, then after testing, like, if you test your code, it may have some bugs. Okay, so you may have to fix it. And if it is successfully testing, if it is passing the test, okay, if it is passing the test successfully, then you can release your software. Release means the word itself, you can release it for distribution. Okay, so after maybe you can give a version number like 0.01 or like zero point 0.1 or something like that. Okay, so the first version, imagine the first version of your software is zero point 0.1, you give a number, so that is the first release. And after releasing it, you can deploy on some machines. Okay, so all the software, no, all the software, like this Chrome is a software, it's a web browser, it's a software, right? So if you just go to the help and about Google Chrome, you can see here there is a version number and there is an official build, so there is a version number associated with it. Okay, so these versions are all related to this uh, just a second, yeah, this release number or build number. I mean, this software, even if it is a very small or very big, this kind of process is mandatory to ensure the quality of the software or the software development, the entire quality of the software development. So after releasing, you deploy it, then you work with it, then you monitor. I mean, once we deploy the code, is it done? No. I mean, there is a chance for like bugs. Okay, so you again do the routine again, like you have to like code, and so the integration, the testing and deployment needs to go on. Okay, until we get a stable working version. Okay, and also after, even after reaching a stable software, are we stopping the software development? No, we are keep on adding the features, right? For example, we have the Discord here, right? We have the Discord, and if the Discord, the company Discord, thinking like, okay, we have created some features, okay, and that is quite stable, and then let's stop the development. We can just maintain the software for a long time, and yeah, we are done. Okay, no, it's not happening like that. If you take the Android application, mostly in each day you may be getting that notification for updating your application, right? Updating the application, you need to update, you need to keep on updating this application. So it's kind of frustrating, but you have to do that. So what is the purpose of this updation? you you will be keep on getting the stable code and also new features. Okay, so these routine, these development and deployment and all these things are actually doing by, I mean, in the back end. In order to automate all this stuff, we have a CI/CD pipeline, continuous integration, continuous deployment pipeline. In a sense, like, you have we have an automated setup in which once you update your code, okay, for example, we have the Discord application here. Okay, so imagine you are a developer and you just created a feature. Okay, you created a feature, and imagine this Discord application code is in the GitHub. Okay, so you actually pushing the feature into the GitHub. Okay, then what happening is that the feature that you have pushed, that is no, I mean that is not guaranteed. Like we don't know whether that will work or not, right? Maybe the developer may test his code on his local machine, but that is not guaranteed. Okay, that working, we don't know, like that is working on all the machine. So that's where the CI pipeline comes. Okay, when you commit or when you just push some code into the GitHub, this CI pipeline, continuous integration pipeline, will start getting active. Okay, and what happening is that this CI pipeline contains some kind of Docker setup inside it. Okay, I'm just saying an abstract thing. Once there is a change in the code, this CI pipeline section will be absorb the latest code into a Docker container. Okay, that is hosted in the cloud. Okay, so you know how Docker works, right? The Docker is like a like you can run any kind of setup inside Docker. So as per um, our plan, I mean our environment that is mentioned in the Docker settings, I mean in the CI pipeline settings, this code will be compiling. Okay, compiling, building, and also it is running the test routine. Okay, so I'm not sure you are familiarized with the testing of the code. Testing of the code is nothing but like, imagine you created a function called add. Okay, add a comma b, you created add a comma b. So how to test it, how to make sure the function add is working? It's simple, right? You can call that function and give some arguments. Maybe you can give 5 comma 5, and if the add a comma b function gives 10 as the result, then it is passing the test, passing that test. Okay, and you can also give some other like some other values like 2 comma 3 2 comma 3.1. So if it is giving 5.1, then that ensures that it is also taken care of decimal points. Okay, okay, so that is passing. So that's how the testing works. Okay, so in order to test the code, there is a framework called gtest. I'm not sure you have heard about gtest. It is actually the C++ testing framework, which is actually having some set of functions to test your software. Okay, easily test your software. So the CI pipeline, what it does is that it will absorb the latest code from the GitHub, and then it will build the code, and then it will run the testing routines. Okay, so we have created some testing routines in our software. So once the testing routine runs successfully, and if it is passed successfully, that means the code is okay. Okay, the code is okay. So I'm not sure if you have seen this tag in GitHub. If you take the diff board, I'm just sharing the link. If you just go down, you can see a branch here. I mean not branch, a tag or like sticker here. Okay, badge is specifically it's called badge, and it's called CI passing. CI is passing. CI means continuous integration. Okay, and document CI is also passing. So what does this means, guys? Like CI passing, this means that this GitHub code is actually going to an automatic integration test. Okay, using this CI pipeline. Okay, CI pipeline will be running on this GitHub code, and if that test is passing, then this badge will be updating. Okay, so here it is passing, right? CI is passing. Maybe I can take another branch. Let me check which branch I mean which code I need to take. maybe okay, mbf ROS. I'm taking another repository so that I can show you. Okay, for this I think, yeah, here also you can see the build status. Actually, this code, okay, this code called move base flex, this code is actually testing in a series of environment. So it is testing on melodic, it is testing on noetic, okay, all this testing is passing, okay, and uh, this is actually testing the main branch. I think this is testing the develop branch, and this is testing the documentation. This is passing the source Debian file and binary Debian file, all this. So basically this badge, no, this badge is actually giving a confirmation that this code is working fine, okay. So if you take some other other GitHub, uh, I just want to show you, yeah, here it is. So if you take the Turtleboard 3 repository, if you just go down, you can see the kinetic devel branch is actually failing, okay, and melodic devel branch is passing, noetic devel is failing, dashing is ROS 2, okay, fox is passing, and galactic is passing. So what you will get is that this code surely work with galactic, and there are some problem with noetic, okay. And if you just press this badge, I think you can able to see the status or something. Okay, it's jump into the noetic devel, and I think we can also see the, yeah, we can also see the status here, that I will explain after some time. So just understand that the continuous integration is actually an automatic pipeline or automatic set of tasks that is doing whenever we update the code, okay. Whenever we add something into the repository, this automatic routine will be executing, and then what happens, it will be like giving you some badges or some confirmation that, hey, this test is passing or this test is not passing, something like that, okay. So we are using various tools for doing the continuous integration. So I mentioned that we are using GitHub, okay. So that is one tool for version control. Version control means you can create projects, you can create branches from it, you can keep on adding stuff into it. So that is actually the coding part, like the version control part. So you can see in this image, in the code part we are using Git, okay. And for building there are some tools. Building means in order to build the code there are some build tools. In order to test it there are some other framework like JUnit. I mean, these are some of the framework. So in order to do the building and releasing, we have the Jenkins, that is what Bharat mentioned. And in order to deploy, or in order to, like, after releasing the code, in order to deploy, you can use Docker or AWS, so that after deploying the code start, your application start to working. And you can extend your application using extend or like expand or scale up your application using some uh, applications like Kubernetes, okay. Then you can monitor the application using Splunk. I mean, these things keep on going. So these are some of the tools that we are using in order to do the CI/CD pipeline, okay. So why this CI/CD is important for ROS? So that is the question that I am trying to answer. So even if you are working with ROS and ROS packages, it's actually a software, right? It's a piece of software. So somehow you have to write this software and you have to deploy it. Okay, so if you just check the Synaptic Package Manager, if you just take the Synaptic Package Manager, just a second, and if you just search for ROS Noitic, you can see a list of packages here. Okay, ROS Noitic packages. All these packages, okay, all these packages we can install using a single click. That means these packages are like binaries. Okay, we are calling it as binaries. Okay, so how this is actually happening? For example, if you just search for diffbot, which is the repository that France actually created, the diffbot, this one, okay, this repository, you can see here the binary files of diffbot here. Okay, so instead of installing diffbot from the source code, you can simply install the diffbot using this one. Okay, a single click you can install. Okay, you can install. So the objective of the CI/CD, then all this stuff, is you have a software, a piece of software, raw software. You have to deploy or release this package. Okay, you have to release this package like this. Okay, so if you release your software, anyone can install your software. Okay, so the releasing of the software can be through like this, like apt binaries. You can, or you can generate the Debian file. Okay, so these list of packages, no, these packages are like .deb file, Debian file. That is actually the packages in Ubuntu. Okay, so the ultimate aim is that if you have a ROS software, okay, in GitHub, how to finally release and deploy your software. Okay, it's similar to other software. There is no difference. Like if you are working with any other technology, like if you are creating a C++ application or Java application or JavaScript application, this method is almost the same. Like from the software development to the deployment, how we can do this, or how we can release your software. So that is what this uh, chapter discussing. Okay, this chapter is actually discussing from the software development how to do the continuous integration, because for releasing your software you have to ensure that the software is passing the test. Okay, continuous integration, and you have to release that version. Okay, you have to release the version, and you have to you can add uh, you can add your package to the ROS distribution. So anyone using the for example, if you are releasing your package for ROS Noitic, uh, whoever installing ROS Noitic can able to see your package. Okay, so that's why you can able to you can able to see the diff board. Okay, so diff board actually France actually released. You can see the release here. There are some releases actually going on. So in 2022, all these releases actually he released on ROS Noitic. Okay, so anyone using ROS Noitic can install diffbot package. Okay, so that is the sole aim of this chapter. Okay, so I'm not discussing further. Maybe next class we can start with the Travis CI, I mean basic stuff. and GitHub Actions. Okay. um, and after that we can see how to release your ROS package. If you have a ROS package, how to release into the public or how to contribute to the open source so that everyone can install your application and try. Okay, so all this stuff we can discuss. It actually requires one more class, I will say. After that we will be jumping on some topics like drones and um, let me check, state machines. Okay, these two chapters, and if there is anything remaining I will be discussing. So that's all for today's session, guys. So maybe next session we can discuss further on the continuous integration. I will announce the next class date maybe next week. um, if I get time, I can take multiple session. Let me check. Yeah, so that's it, guys. So if you have any questions you can ask. So today we have been mainly discussing on the NVIDIA Docker, importance of that, and the testing and deployment, why the CI/CD pipeline is important to us. It's similar to any other software. Okay, there is no change in ROS. Okay.
Yeah, just to add on the CI/CD, basically the products which are developed in the companies, they will use agile and safe agile methods. So all this will be follow the CI/CD, and then it is just a
Yes.
process when the project kicks. So agile and safe agile are the main things starting off as a project
Yes,
side.
yes, exactly. Yeah, thanks for the addition, Bharat. So that I think we can discuss next class. So you will get a clarity, like as of now we have seen like how to create a ROS package and how to work with different uh, things in ROS. But now we are actually seeing how to like deploy it and how to release your software, those kind of stuff. Okay, so that is actually quite interesting because if you want to contribute something to the community you can do that, and after creating your release, after adding to the ROS distro, you can add it in your CV like, hey, I have created this software, you can install it and try it, something like that. Okay. Okay, so next class I think we can discuss, guys. So thanks for attending. Like if you have any question, let me know. Like I have few minutes, so let me know. Like either you can comment or you can ask. Okay, let me know if you have any question, guys. Okay, I hope you don't have any questions. Uh, okay, so we can conclude, guys. So see you in next class. I will announce the next date. I was also busy with some I mean functions and all, so that's why. Otherwise, we can able to finish it and start with rows 2. Yeah. So
Yeah, one last next week is Sankranti, so 14th. Is it will be there or we can
uh,
postpone it? Saturday is Sankranti.
14th. Yeah, maybe we can do it before that because yeah, I think maybe on weekdays or something we can. Yeah, Saturday we can skip. No problem. Okay.
Yeah, okay, thanks.
Okay, guys. Thanks for attending. Bye, everyone. Good night. Good night, everyone. Bye.
Yep, bye bye.